recording. Recording has started. Okay. So 1 second that I just need to switch to my presentation. Here it is. So good morning. My name is Franca GARZOTTO. I am your teacher in this interaction design studio course, which has composed of 2 modules. One is called Interaction Design Studio, and the other one is called Applied Informatics, and is managed by teachers who have some expertise and background in computer science and engineering. So that is somehow the technological part of the course. You all know in which situation we are. We will do our best to organize this course so that you can learn, you can have a good experience of projects, of collaboration with us and with your peers. But of course, you must be, the conditions are extraordinary and we're in an emergency, and you must be very patient about what will happen during and after the lesson. Particularly, we are video recording the lesson, and you will be able to see from the chat the link to Teams where the video will be generated, could be accessed. I will also prepare an online document in which I will report all the links to all the videos of my part of the course, so that you can go directly there without getting crazy of finding the link here, there for the various courses. If possible, we also create a YouTube channel so that you will find all the videos there. The videos are done on the fly. So even though we prepare for giving each lesson, they're not the best possible quality. So we will not be happy if you disseminate them, if not for other reason that at the beginning, particularly people is in their house, and again, it's something that is related to an extraordinary situation. The other aspect is that sometimes the platform that we use, which is Teams by Microsoft, crashes. And when it crashes, we might have to stop and to restart everything. So be patient. Who is going to... Okay, that's
Galaxy S20 手机记得单页全新再进化。
Everybody, thank you for being here. This course is the lessons today, and every morning in the course we will work on the module Applied Informatics of the broader course, which is called Interaction Design Studio. So it's a sort of administrative issue. So the course is involved two teachers, one teacher for the computer engineering with computer engineering background, and a teacher with design background. We collaborate together in the design of the course. We collaborate in the project and evaluation, but we split our lessons, and also we split the assignments and that we ask you to deliver for the project. And we also organize evaluation so that the evaluation project from a more for a point of view, a design point of view, evaluate things from a more technological point of view. So remember today in the morning until at least Easter, if not later in the morning, you will have to access this virtual room, and there will be me or my collaborators giving lectures for the module Applied Informatics, so for technology. And in the afternoon, there will be my design colleagues giving lectures on design. So this is our first lesson. and this is what we will talk about. I will introduce who we are, so the team of person and tutors that who will contribute to this course through lessons and tutoring and supervision of your project. I will explain what is the content of our lectures and what is the schedule of the entire course. We will introduce some basic concept about the exam, and then say the administrative part is over. Then the lesson today is about in advanced interactive technologies with basically examples of projects. Example of projects that use non-conventional interaction, so tangible and gesture-based interaction, full body interaction in smart spaces, discussing this kind of interaction paradigm by examples. The second part of the lecture, it's about projects related to virtual reality and augmented reality. So this that you see is a checklist of possible ideas for your project. And then there will be a more methodological part about what is interaction design with the cap of the computer engineers, and a sort of engineering perspective with interaction design. And then somehow being exposed to this content, I will go back again to what the exam is, so you will be better understand what the exam is and how to do it. And then there will be question and answers. So this is my team. The team I lead a laboratory that is called Innovative Interactive Interface, and I lead a multidisciplinary team of 7 PhD students, 5 master students, a number of research assistants, external consultants, people who have a background in different disciplines: software engineering, human-computer interaction, psychology. We have 2 psychologists, and design. We have Julia, for example. She comes from the design school. She has a degree in a master in design here, and then she has joined our team. Eleonora and Silvia are the 2 psychologists, and well, okay, the majority are engineers. The main focus in the last 3 years is innovative technologies and application in learning, health, and well-being. So that is our main focus, but we have a wide range of projects also on different areas, including e-shopping, retail, fashion, tourism, and cultural heritage. But then we decided to focus on these 3 application domains: learning, health, and well-being. And our characterization is that we exploit innovative interactive technologies for this purpose. So we have multidisciplinary cooperation with therapeutic centers, hospitals, care centers in Italy, in Europe. We work with a number of companies. Currently, we have a project with Team, with Reply, with IBM, and also with partners abroad. And we have a regular collaboration with University of Milano Bicocca, Catholic University of Milan, MIT, the Media Lab at MIT, Georgia Tech in Atlanta, and University of Southern California. This collaboration is typically managed through our PhDs or research assistants who go there and do joint research, or people from this institution coming and working with us. So actually, we work with any kind of person. So we have worked with very young people and to the elderly. But our main focus is, even so, again, what Also because what you learn with children is something that you, in some cases, can apply to different contexts. So here, children are depicted, but we also consider adults, young adults, or old people who have some special needs. So in general, we look at our users from the perspective of their needs. What do they need to do with the technology that we develop? Why they need technology? And we focus more than something, say, operational, something that helps you to perform a given task faster. We focus more on developing supporting other dimensions, so the development, cognition skill, or motor skills, or socialization and communication skills, or even imagination, creativity, and emotion. So we work our technology in most cases try to improve some functionalities in the psychological, intellectual, and emotional sphere. And we work with a wide number of technology. We've tried many of them that range from technology in which you use motion, in which you use robots, smart objects, you interact in large environments, you interact with virtual reality. And the last one, in which we have been working since the last 2 years, is conversational interaction. What are the common features in these technologies? They are non-conventional, so they are something that is beyond the most advanced way of using technology. In that sense, they are advanced, they are non-conventional. They involve multiple parts of our body. So our entire body, so when you have motion-based interaction, our touch and hands when you manipulate robots or smart objects. Again, our body and our entire senses when you are in a smart space, in a multisensory smart space. They involve our eyes, our visual senses, mainly when you're working with reality, in which the main mechanism of interaction is pointing to something. And then conversational interaction is basically, for us, is text and speech based. It's not just a chatbot. Text chatbot is any interaction that involves natural languages. Our specialty is speech-based interaction, but as you will see in this course, we are also working on. We will expose you also to more to text-based conversational technology. And this is a bit larger than the other one because we do expect that in the future, conversational interaction will be pervasive. It's already a bit. I mean, it's already pervasive. So you can use it. You use Siri on your smartphone. You interact with your car by voice. You might interact with your TV by voice, but when the quality of this communication in natural language will improve, and it will improve soon, at that point, the prediction is that conversational interaction will become the main way for people to interact with technology. So so it will be universal, it will be spread everywhere, and we will totally change the way we use technology. That's the reason why we address this topic in the course. And the idea is that, so I will give you a presentation with example of all these technologies, and you are allowed to, and then you will see how they related to your project. So here we are. We will present this technology for non-conventional interaction. Again, where we, there's a mistake here, we cut it down. Sorry, there was a, I forgot. So we will speak about technology for non-conventional interaction, what is called embodied interaction, which the emphasis in different parts of your body, and virtual reality as an example of a different paradigm for interacting with technology. We also pinpoint in this presentation the role of interaction and the role of content. So it's not just, which is I think very much related to the fact that you will be communication designers. So you will communicate, you will deal with content, because content is the very essence of communication. So it's not just so when we present this project, you will see that all this project is not just pure interaction, not just pure manipulation, not just pure gesture. There is a design of the content which is rather sophisticated. All this will be presented by examples. So I'm not going to the detail of the technology. It will be presented through example that we did in our lab or in other places in the world, and traditional devices. And this is on content and interaction intensity experience, meaning, as I already said, that is the quality of the experience is related to the way people interact and to the quality of the content. And then a part of the project, of the lessons, will be about web technology. You will be introduced to some basic concepts and technologies with hands-on, which means we will try to do live exercises during the lesson. Still to be that will be an experiment. We hope that, anyway, the idea of hands-on is that we give you assignments and either in real time or giving you some time and then recover during the lesson. Ask you to do some exercises related to web technology. And this is the schedule. So we are here, 20th of May, Advanced Technology for Content Interaction Intensive Application. This is what I will speak about. And the other content will be from requirement to design and engineering perspective. On the 27th of May, there will be a collaborator from my lab, which presents an overview of what is called web architecture, so the general structure of application that rely upon web technologies. And also we discuss the design and technological trade-off between creating websites, web application versus web app, native web app. So web app is something that you download on your computer, on your device. A web application is something which is always connected, but you will see the difference also from a technological perspective. Then a lesson that I find fundamental is about conversational technologies. We have one of my PhD students is a specialist on this field, is collaborating with MIT to work on this topic. He works on emotional detection from speech. So the idea that when you communicate, you do not communicate only content, you communicate also emotion. So he has developed a technology to extract emotion and interpret emotions from speech. He will not talk necessarily about this specific research, but in general, he will provide you an introduction of conversation technology. Well, we will do part of this lesson together. And you will also do some hands-on. So you will create, in a couple of hours, you will create your own chatbot using a technology called Dialogflow. Then on 17th of April, we will present web technologies. Sorry, it's written finora 12. Yes, because the lesson must finish at 12 for a number of reasons. And And in the and that web technology content will continue in May. The main topic will be HTML, CSS, and Bootstrap. These are the things that we plan to explain you. But then you will see how they play in the exam. So the whole morning that the whole morning is related to at least till the 1st of May. Sorry, till the beginning of May is devoted to the technological part. The afternoon here that you see on the right side of the table is related to the design part to my colleagues. I have depicted some of the topics that they will deal, but this part is not my responsibility, and they may have changed. So this is a subject that we agree about. They will be presented in the afternoon. So I'm not responsible for this part in the sense that it might change a bit. So you will have the schedule for the design part in the afternoon. In this afternoon, there are three milestones and three important deadlines. On the 24th of April, there will be this called a research presentation, which is basically the presentation of your research done trying to defining the problem that you want to address in your project. Because, okay, by the way, of course, this is a project-based course. It's a laboratory in the classification of courses. So it's basically the lessons are preparatory to give you preparatory for you to design your project and to create your project. That I will explain you what is. But anyway, there will be research presentation in which all groups present the results of their first step of work. And the first step of work is user research. You do a research. Research is a broad term. You're not going out and you are reflecting and conceptualizing and on what are the user needs and the user goal. What is your problem? What is the problem that you want to address with your project? How to do user research will be explained by my design colleagues. There are many ways to do user research. It's not just a solitary, solipsistic reflection. Is an analysis of users and needs, involve other users, involving people, and given the difficulty of contacting people today, you will see in a moment which kind of problem of a project you will be requested to do. Anyway, so on the 24th of April, there will be you present the definition of your problem as a result of a research process. Okay, for research is user research, gathering data about the user, reflecting, defining requirements, needs, and goals. You will also, by the way, you will see how to do user research with my design colleagues, and you will also see the engineering perspective of how to represent the result of user research. So there will be a flow, a day-long flow of presentation, each group of which present, hopefully in presence, more likely not in presence, your research. Then there will be, and then there is another milestone, and the second milestone is concept presentation. Again, all group will present their idea of how to solve that problem. So what we call concept. And then there will be tutoring till the final exam, which is scheduled around the end of June. Everything needs to be confirmed, of course. And So let me stop 1 second. And I have people waiting in the lobby. Do you have any? Okay, I will stop recording. Topic today, the exam. I'll speak about the exam in general, but then I focus on what we expect from you concerning technology. We have been struggling about, in the past we gave multiple topics, several topics for the exam, leaving the students free to choose the favorite macro topic. This year, after considering again the current situation, we've focus on something, on a problem which is related to the current situation. So we ask you to design a technology enhanced solution for a broad set of problems. During a public health emergency, people need help. Need help for being informed, for stay up to date, for learning, communicating, collaborating, working, moving, entertaining. Okay, I should add entertain actually here. And was a bit pessimistic, but you also need to entertain. So people, there is a total change of perspective in our life. Everything seems to change. We are forced to stay at home, and that's applied from children to the old people. So how can technology help people during such a public health emergency as the one that we are living? And there are many possible ways to look at the problem. There are many possible targets that you can consider. So it's really broad. It's just do something that is inspired and is particularly motivated in this tragic period of public health emergency. So that is the invariant kernel is public health emergency. And around it, you have to think about specific classes of users, specific aspects that you want to tackle. Again, you want to have people to be informed and stay up to date. They want to learn. You want to help them to learn. Like us, we are learning. This is a teaching experience for me. It's a learning experience for you. There are children at home that do not go to school, and someone needs to take care of them also from an intellectual and educational point of view. There are very young children at preschool, and what does it mean learning from them, which is of course learning and play, but something related, we want to have something strongly related to the problem that we have now, that apply to all people and to all aspects of our life. That said, you can, when you imagine how can technology help, by the way, we can also think of public health emergency from the perspective of people who manage the crisis, people who need to, ranging from the police to the doctors to the managers of public administration, to the people in justice courts, everything. Everything has a problem today. Any category of people. Choose a category of people, choose a problem, and show how technology can help. That is the problem. That is your project. And you can imagine any technology presented during the course, and even other technology that we do not present during course. For example, this year, given the current schedule, we didn't speak about data science, about data management. During health emergency, there are problems of data management. There are a huge amount of data going back and forth. Data are important to make prediction, to make analysis, to support several aspects of this life of our life. So any technology presented in the course, including traditional technology. So you want to do something which is a web app with a special service, that is more than welcome. If you want to do something which use conversational technology, or you want to make a merge, you want to make a service with conversation technology, or if you want to do some smart objects, and again, a combination, you can make a service that involves a smart object, and so on and so forth. Because the good thing, the good news is that you do not have to implement anything in this course, because considering the delay of the start, and considering also your profile and the difficulties to give you side-by-side teaching, we have decided that this year there will be no technological output in terms of technology created. So you have to design technology, not to create it. Of course, if you can create technology, it's perfectly okay, but we do not expect that in this small period of time, with the kind of support that we can give you, we do not expect that you're able to deliver a group, even minimally working prototype. So you will have to do this work in group. It will be a group project, and your work is organized in two parts: the design work and the technology work. The design work, you will see this afternoon what my design colleagues expect for you. From the schedule that I presented before, you see that you will have to do some research, user research, and make, which generates a presentation about your needs, your users, what they need, what they want, and then concept in which you propose a solution. Okay, they call it user research and concept. And then you have to deliver something about technology. In general, you will be evaluated under these two perspectives, design and technology. We will evaluate you somehow together, because all teacher has experience, are specialized in one of these parts, design or technology, but they are competent also on something about the other part. So we together, we evaluate from two perspectives, design and technology. And your evaluation will be evaluated on the basis of materials and project presentation that are related to your design work. And the project presentation are three, as I mentioned: presentation of your research, presentation of your concept, and final presentation. Where concept presentation means the very initial idea how you want to solve your problem using technology. Then the final presentation will be a detailed refinement of this initial concept. And from the technology's perspective, you will be evaluated by some deliverables, some reports of your work. And what you have to deliver. So what is the basic for us to evaluate you from a technological perspective? There are two things that you have to deliver: a working website about your project. The idea that, okay, we teach you something about web technology. We expose you to, we give you an overview, so that when you speak about Bootstrap, you know what it is. CSS, you know how to use them. And by the way, I will do a bit of inquiry during this lesson to see how many of you are really, how many of you know what. And then, and the website will be about your project. You have to present your project on the web. You're totally free to present your project as you wish. My recommendation is to present your project as a venture. So imagine to be a startup. You are a startup because you have the size of a startup, 3-4 students. We will discuss how many people in the group. It's an issue that somehow depends on organizational aspects. my suggestion, also considering that you are working remotely, is to have no more than 4 people per groups. Okay, you in general, or I mean, 2 people are okay. 3 people are the optimal number is 3. The optimal number is 3, but if you are 2 is okay. If you are 4 is okay. In general, 4 people, it's very difficult to organize the work in group of 4 people, and a statistical results in the past years was that group of 4 performed less well than groups of 3 or 2. The organizing the work was more difficult, and the outcome was not as high quality and as we expected. Since of course for a group of 4 we expect a bit more work than a result which is bigger than from a group of 3. For obvious reason. In principle, there are more human resources in a group of invested by a group of 4 with respect to a group of 3. So think very well how to manage and to organize your group. Also take into account that you will not have for a long time, unfortunately, the possibility to have face-to-face meetings. Anyway, you are the size. Your group is the size of a startup. 2, 3, maximum 4 people. So a good way to present your project, I think, is to exploit your creativity, is present yourself as a venture, as a small startup. You can, in this startup, you can present only this project, which could be the main product. Startup start with 1 product. But if you imagine to be a more mature startup, you can have a portfolio of projects in which this product is the main one. So find a creative way to communicate that you are a great group and you have a great product, and the product is your project. And then, so we will evaluate this. It must be a working website. We invite you to use the technology that we explained during the course, but that is not strictly mandatory. You can use any web technology you may be more familiar with. As far as it is a running website, published according to the guidelines that we give you. Okay, and then the second part that concern my module is technical documentation of your project. And this is give you the structure of this technical documentation. So that is what, for me, is a technical document that you have to deliver for this course. A cover. Oh, I forgot one thing. Table of content. I forgot. Table of content with page numbers. Okay, so your technical documentation will have a cover with your names, of course, project title, but important to please put your name, your ID, and contact email for group member, plus a short abstract about your project. Then table of contents, it is missing. Okay, table of contents with page numbers, so number your pages, a short introduction what your project is about. Then a section is about need, goal, and requirements that are conceptualized using a model that I will present during this lecture, which goes NGR model, integrated with a short textual explanation. So very concisely tell me who are your users, what are their needs, what are their goals, and what are the key requirements of your system. In some cases, you can, the idea of customer journeys is applicable, not in all cases. So if applicable, add an overview of the customer journey, which is something that you also have to present during research and concept presentation. Then present user scenarios. That I will go into the issue of what is a user scenario during this lesson. But basically, a scenario is a visual and textual description of how a user interacts step by step with the system. So I want to have a story. Tell me a story of how your system is used. And for me, this is the design specification of the user experience in terms of how you use it in a given context of use and what are the effects of such interaction. And then we want to have the general technological architecture. You will see examples to inspire you. Is basically a diagram with boxes and arrows that describe the main element, the main ingredient of your technological system. So which are the data? What are the functional components? Which are the functional component means there are part of the system, of your system, that will be responsible to manage some data. Another part of the system is responsible to interact with the user. Another part of the system is responsible to send messages to other systems. So what are the data, the functional component, and the devices? So the user devices, and there is any sensor actuators. You will be, the tutoring for us will be mainly on explaining you what we want with user scenarios and how to describe a general architecture. Okay, so our support will not be in programming this year. It will be in helping you to conceptualize what are the right technology for you to adopt in your project. So that is sometimes called technology design, this general architecture. The design of the technology that you put in place that would allow your team, your startup, to implement the system. And our main focus in the tutoring will be here. Discuss if it is what you have in mind is feasible, what is the best technology for it, making maybe some cost analysis, because of course everything in principle is possible. You can also go to the moon. Well, is that cost effective? Is that economically feasible? And then we expect from you a short competitor analysis, which means a brief overview of similar products or prototypes that you find on the market, in research environment, in startup, in Kickstarter's crowdfunding initiative and similar. And then I ask you to conclude with a value proposition, why your project is a great solution for the problem, for the user needs. Okay, so that is a typical, so the accuracy of this document in terms of accuracy of content, not only accuracy of the layout, it's important to help you learn how to present your project for example, to a team of investors, to a customer who needs to be convinced that you provide a good solution for their problem, that you're able to analyze the problem, that you're not able to imagine good solution in terms of visual quality, communication quality, but also with a realistic approach with respect to technology. So you have to, and you have to argue here why, and that you argue here that you're really the best and your solution is definitively well thought and high quality. So how you will be evaluated from my part? Again, the final evaluation is negotiation, is a collaboration, is based on the collaboration between myself and my colleagues, design colleagues, that for me, in my evaluation matrix, matrix, when I type down my comments, I evaluate the active participation to tutoring. So how much we really, in spite of the difficulty, are able to interact. Because, by the way, this year there are no excuses. You are remote. There are no excuse for not participating to the tutoring. We will try to schedule and to organize the schedule in the best possible way, giving you time slots to connect and to discuss your proposals. So we expect that you are active, that we will try to assign you some deadline, some task to do for the following weeks. Not necessarily that you might not. In some cases, for example, because there is this interplay between design and technology, maybe we can say, okay, in 2 weeks from now, please bring this part, this part, this part. Anyway, active participation to tutoring is important. Of course, we evaluate also the solution. I mean, if you have address a big problem and you propose a problem which is particularly complex, and you provide a solution which is particularly challenging and original and big, okay, that is of course a part that we will evaluate. So complexity and originality of the solution. This does not mean that you have to do something very complex. Remember, it's not, maybe I could remove, but I could say size, not complexity, because otherwise it can be misleading. Size means, otherwise you say, okay, I've done something very complex. I mean, complexity per se is not a quality. I mean, it's how well you address a problem. But in some cases, you imagine a complex situation, a large situation. In some cases, in the past, we had students, let's say, they provided a very, very, very small, teeny solution. And of course, we have to differentiate the output. If people invested more, if people were able to design a wider solution, of course, we take it into account. On the other side, there is originality. If you do something that really is, wow, I never thought about this solution, or that has no competitors, of course, that is a plus. I'm not saying that you must be original at all. I mean, you can do something even for which other similar solution exists, and you do it better. Okay, so it's really a balance. So don't think we have to be present to all tutoring without saying anything. No, you have to be present to tutoring, and the tutoring must be effective. Oh, we have to do a very complex, intricate project. No, try to make to do something effective for the problem that you addressed. We have to do something originally and cool. No, you have to do something useful. And also what we evaluate, because I mean, when you propose something, that must be technically feasible. Feasible means that there is a clear plan of how to implement it and to deliver it. So something that, again, you can imagine an application that help people in this moment to go to the moon to escape from the virus. That, of course, great idea, not feasible. And also, as I mentioned, we want to evaluate the completeness and quality of your technical documentation, the quality in terms of message, of content, not only of layout. And then we will look at your website, which is the only running artifact. We will look at, it must be complete in the sense, complete means, okay, it must offer, it should not be a static page with no links. It should not be one page, one HTML page. We expect you to structure your content, to provide some interaction features. So completeness in terms of content and interaction, the communication quality of your content, if it is, I mean, if you communicate your project well, from really a communication impact perspective, the quality of the user experience as a whole, and also the technical correctness. So technical correctness means it must work. I must click, and when there is a link, I must be able to click it. I must be able to, the website will be published. So we will give you some indications about the minimum technological requirements for your website. And these are the dimension for us, for our evaluation. So I will take a break at the moment for all of us. I will stop recording. I hope it is recording. Yes, it is recording. Okay, so our robot Ele was inspired by Tega and by Huggable. 1 second. But again, it's much more low cost and much more. Okay, and again, it's more integrated with digital content. So Tega is going to be produced for many thousand euros. Ele is like Sam, the dolphin, is a toy with a small motor controller for the different parts of the body that you can buy for something like 30-40 euros. We put some equipment inside, a camera. So basically there is a camera here on top, on the head. Speakers, the controller is a Raspberry board. And basically the idea is that this is on your left. What you see on your left is a control panel for the therapist, where the therapist can control different part of the body, or can have a combination of behaviors that reflect among a situation, such as saying hello, or to manifest a given emotion, such as behave like being happy. So in this case, all the part of the body move, or be afraid, behave like being afraid. In this case, the ears, go down, and the proboscides also go down, and similar. So, and then they can control the various parts. They see, the therapist can see the child. So it's sort of, video call, even though the child is not aware that he's being recorded. So the child, like in Huggable, she's thinking that she's interacting with this object. So like in Huggable, the caregiver voice is recorded and transmitted to the child through the toy. The caregiver can control the different behavior. And something that is not done, to our knowledge in previous project, is that we can, using the video camera, we can trace the emotional state. So Ele is connected to a server, a web service, a web service, which is able to process the video at runtime to interpret the video in terms of emotion: joy, disgust, contempt, anger, fear. So the therapist not only can see the child, but can also monitor and record automatically both the sound and the different behaviors, that the different emotional behavior that the child had during the conversation. Okay, so this is the child experience, this is the remote caregiver experience. As I said, automatic data gathering, visualization and storage of behavioral data. So you can store the video, and there are also ways to analyze the emotions during a conversation. Emotion analyzed from videos, not from the voice. You will see we have done some work. I mean, a project, a large project that we have on emotional conversation analysis is based on speech, and is very innovative. For extractive emotion for video, there are standard commercial web service that you can use. We did an experiment, because that is also part, I think, of your project, an issue that you should reflect on. How can I validate the quality of my project? If I had time, which you don't have, but if you had time to do some empirical study to validate your project, how would you organize it? And here is an example that we have in our publication that you find on our website of the lab. We have many examples of empirical studies. And this is what we did with Ele. We made a study comparing the interaction with a caregiver with the interaction with a caregiver mediated by Ele. So here, with two different sets of subjects, it was a control study with two different sets of subjects of comparable characteristics. Here, the caregiver was telling a story, and here the caregiver was telling the same story through Ele to a different set of subjects. And here is the situation. There are many lessons learned from our work with smart objects, and the lessons learned are in general about our work, our research, and our evaluation with smart objects. One is the issue of familiarity. So it's important that you do objects and you imagine object situation in general that evoke experience the subject have in their life. So, for example, the shape of Theo, the robot, was inspired to the Minions. Puffy was inspired to Big Hero 6. Well, Big Hero 6. Polypo was inspired by popular games for children. The second is minimal design. So you do not need to have a very complex feature, both in terms of physical and digital characteristics. So you don't need to have minimality does not need this, but it needs does not need, and then this is certainly the picture on the left is certainly too complex, but you can imagine something in between. So the object and its content should be visually attractive, but visual property should be strictly functional to the learning goal of the experience with the subject. So to the goal, learning or other experiences. It's put just exactly the feature that I need to the users. The other aspect is that multisensoriality is important. People, we interact with the world through our multiple senses. In many cases, you can also use two senses, which is typically visual and audio senses. But typically, if you add more senses, the experience can be more relaxing, more engaging, and more pleasant. Okay, and the other lesson is customizability. So one size does not fit all. So it's difficult to find something that is appropriate for all the possible users, even with the same profile, even within your main target group. Certainly, people use technology in many different situations, in many different contexts, and for many different people. There should be a way for caregivers or for the end user to adapt object behavior and stimuli to the need of each specific subject. I anticipate here 2 words about another system that you will see in detail in future lessons, namely in 3 lessons from now. But in case you want to start thinking in terms of conversational technology for your project, even if you will not have that lesson before 2 weeks, I just anticipate that you can imagine various kinds of systems that use a conversational technology. This specific system, which is will be presented by Fabio and us, and me, in 2 weeks, is able, as I have already anticipated, to detect emotion from speech. So it engages the user, in this case, the user with some form of cognitive disability, in a number of conversations in which the user has to interpret the spoken sentence from a regular PC. They have to interpret the spoken sentence from an emotional perspective, so they are asked to say, what is the emotion expressed by this sentence? And they are invited to, and they are asked to produce sentences with a given emotional tone. And just to comment this last picture, there is you have to think technology in a continuum between what happened in the digital world mediated by technology and what happened in a world in which technology is not there, and people just use paper, pencil, and colors to do something. And so you have to imagine technology in a real context of use as part of a larger goal and a broader set of activities. So that is, I'm not going to get into this detail, but just to give you this, say, philosophical view that technology is part of our life, should be smoothly integrated with our life, must bring benefits which are not only functional but are also in other spheres such as emotion, well-being, and should address human needs from a broader perspective. So that said, we take another break. I stop recording. And the content that I want to discuss in this part of the lesson is technologies for smart spaces. If it is not shared, let me know. So smart spaces, again, the idea of smart spaces is that any physical space, indoor or outdoor, which embeds connectivity and sensing and actuation devices. So these elements are smoothly integrated in the texture of the environment, of the physical environment. They're hidden to the user, to the persons. You don't realize that technology is everywhere surrounding you. So and the space is smart because it's able to there is a way to control these devices, these sensory effects, and the system is able to sense the user and the environmental phenomena. So the fact that the user get in or out of room, that the temperature change, that humidity change, that people make some gestures. So sensing the environment and sensing the user. Actuating is creating some perceivable effects that transform the environment and change its state and provide new stimuli to the user. So we focus, again, the underlying technologies, of course, IoT, same issue as before. But there is another technology that, if you want to sense the user, is motion sensing. It's motion sensing. Again, I need to, okay. Last time again that I admit people in the lobby. Okay. It's motion, and it's this sensing the presence of the user. As I mentioned before, in front of a question, why Kinect is Kinect still used? We have used intensively Kinect because it is really a good technology for recognizing mid-air gesture, body movement, and body position in space. It's simple, it's low cost, it's relatively easy to, can be programmed. And so far, unfortunately, it's the main solution in the market, even if it is out of the market and we're still waiting for a new release of new technology. There are technologies from Intel that can detect mid-air gesture, but the distance between technology and the human is much smaller, must be much smaller than with the Kinect that has a range of sensing of 3 meters from the device. Okay, so Kinect is able to detect the skeleton, the joints of the skeleton in a given space. So Kinect 1 was able to detect only 2 players, and Kinect 2, the current one, up to 6 players. And we do not know, the new technology, how many players will be able to support. Okay, these are the joints. So so there is a model of the human. So the Kinect takes data about these joints, and so it's able to reproduce this silhouette here. even though his Kinect to a particular is also good, able to take the shape, the general shape of the user. It's based on RGB camera, 3D sensors, a multi-array microphone. Here are some technical specifications if you're interested. And then there are a number of Kinects, a number of devices inside it. So it's an aggregation of relative sophisticated pieces of electronics with a good set of API with a built-in set of software to detect some basic gestures. So there are some gestures that you do need to program. They are built in with the Kinect, other that you need to program. So these are about. So these are examples of projects in which we use simply Kinect and screens. The playground. This is a playground for children, and they need to hit the bubbles. Every time a bubble is hit, there is a sound feedback. They can hit, they can use a different part of the body, and which part of the body must be used can be configured in advance. So they can hit with the head, with the legs, with the arms, with both of them, with just one. So it's a good exercise from a psychomotoric viewpoint because it promotes cooperation, motor coordination between motor behavior and attention. This is another one. In this case, the goal is to help children control their posture and have a body awareness. So the Kinect, as you can see, here is the camera. The camera of the Kinect can reproduce the silhouette of the entire body. They cannot process all part of the body in terms of movement, but the video camera reproduces a shadow, the profile of the body. And in this case, the child has to superimpose so there is a built-in representation of a shape, and the child has to overlap as much as possible to cover the shape with his or her body. Like in this case, and using also objects, physical objects to fill the shape. So the shape is the shape of the body, but it can be integrated with objects. This is another game at the same time. The child has to move and either to hit or to avoid the object, depending on the nature of the object. So they have to take the cookies and to avoid the bombs, or to have to take nice objects and to avoid the bombs or aliens. There's another thing in this with a different visual background. It's more for older children, older people to do exercise, moving and hitting the different part of the silhouette. Here is a similar play with two people that need to coordinate their action of hitting something. Then we moved from a project with Kinect and screen only, which was still example of interaction in space, to a project related to smart spaces. And this is our flagship project, which was developed with the support of Politecnico di Milano, who gave us a Polysocial Award, which is an award given to projects that have a high scientific and social impact. Okay, with our technology, we can transform any physical space into a magic space called Magic Room. Using a cyber-physical system called Magic. A cyber-physical system is any system that integrates in an advanced way sensors, actuators, and different devices and computers. Can you hold for a second? I need to tell my daughter that I'm giving lessons, so please leave the room and don't do. Cecilia. Okay, sorry. People don't understand that I'm doing some teaching. Okay. Okay, so this is how the smart space looks like. It's a magic space for play, learning, and socialization. And it's there are a number. It's multisensory in that it provides a number of visual, auditory, tactile stimuli. The paradigm of interaction is really embodied interaction in a wide sense, with multiple forms of embodied interaction, because there is manipulation of gesture, manipulation of object, mid-air gesture, and movements, all integrated in the space. It's not the first example of multisensory space. There were other spaces in the current literature. A previous version of this space was developed by us in a previous project, but there are also development in Spain. This is Land of Fox. Mediate is also developed in Barcelona, and Snozeling is a commercial product, which costs approximately 150,000 pounds, because it's an English product. Our system has the advantage of being extremely flexible, extremely open and customizable, and extremely low cost. So the overall amount of the cost of the equipment is approximately 6,000 euros for the entire equipment. Then there is, of course, at the cost of installation and reshaping and restructure the room that must be, as we saw before, totally empty room. So this is the room that we started. We made installation. We have 2 installations in 2 schools near Milano, 1 installation at a therapeutic center in Milano, another installation at a therapeutic center in Rome. I mean, you have to start from an empty room. You have to cover and restructure and change all these interior elements, because the room must be completely, as you see here, must be completely regular for the purpose of the projections. Okay. What is in the magic room? In the magic room, we have a front projection, a projection on the front wall, a projection on the floor, audio system, a number of smart objects. So we integrate also the magic ball, the dolphins. There are a bubble. There are a number of smart appliances, such as a bubble maker, aroma emitters. There are a number of smart lights, either on the floor, or on the walls, on the ceiling, and the mobile smart light on the floor, and then the Kinect as a motion sensor. The technology behind our smart light and smart appliances is commercial. You buy it at Media World on the shelf. You just need to know how to integrate it, because it's basically, for smart appliance is on off. For smart light, Philips, for example, as well as other products, they come with their API to control intensity, color, and other visual features. Example of smart object are this. This is called ERA. Actually, the sphere, and it's meant to be the transition element between the digital and the physical world. It includes smart lights and an FRAD reader, so that it can recognize objects and personal badges for the people. So children, when children or people that go in the room, they make themselves recognizable by the room by using their personal badge, their personal tag, and put it on top of the sphere. These are also physical objects to do to simulate play in a supermarket, and this here on the left, on the bottom, this sort of four side shapes. This contains object with multisensory properties. Again, the Kinect is the main element. We mainly consider the use as 2 children or more. Even though with Kinect 2 we can get 2 more person. And this is an example of. We will go back to this example later, because it exemplifies what is the information architecture, and it's an example of software architecture, general software architecture that you need to provide, and not at this level of complexity, but need to provide as part of your documentation. And this is the video. Okay, so this, as you can notice, was a huge project. It was done in collaboration with these colleagues from the Department of Design, of Mechanics, and chemistry, materials, in material engineering, chemistry. This is how our lab, this is the testing lab for the Magic Room that we have in our lab. So we deliver these nice things, but what we work with is somehow less nice. But it's available to do any possible solution. So there is a person who asked me. Okay, please. Someone you has control. I can't hear you. Okay, I think that. Okay, let me see what happened. Oh. Okay, guys, I cannot get control of Teams. 1 second. It seems that I'm not able to take control again. I apologize, I cannot get control of Team again. Oh. I will close this. Close this. Okay, Teams does not work anymore. Crash. Guys, our project and other project, the detail of which can be found on our Polysocial Award website at ludomi.polyme.it. To give you inspiration, of course, you will not be able to share its pose until you return to the share window. Sorry, yeah. Initially, before the coronavirus, we planned to bring to give you some project for the Magic Room, which is really a very open and challenging environment. We had organized school trip to the places where these rooms are installed, so that you could see it and try it in its, not just in our lab, but in the real setting with real teacher and real students. Of course, now, sadly, schools are closed, the magic room is shut down, but if you want to imagine a project in which the magic room, assuming that people have a magic room at hospital or a magic room at home, and you want to imagine some project for the magic room, which is related to the general problem of alleviating the human pain in this period, or supporting people during this emergency period, you are allowed to do so. Of course, I mean, we will explain you what can and cannot be do here, but if you invent a new activity for the magic room, it's okay. If you invent something which is combined with smart objects, not necessary for children, for any people, it's okay. And also, if you want to invent something for virtual reality, in a minute I will give you an example of virtual reality project. That's also feasible. Or you can have something with more standard technology, such as tablet and smartphone and PC only, and still come out with a very original and sophisticated and effective project. So I stop share for a second. I just look and take the other the slides on mixed reality, and I will share them. Okay, these are not shared because I shared the specific slide. Okay, 1 second, and I share them. Okay. Okay. So these are example of project using a technology which is not based on sensor, actuator, IoT, but is mainly based on visual contents. There is a continuum between the physical reality and the digital reality. So now we live in a physical world, but the presence of technology in our life make our reality more and more digital. And when we talk about the virtual continuum, in which we extend, in which we have technology that give us only virtual experience, or technologies that give us virtual experience and real experience, and from two possible perspectives. We see the real world and we superimpose some digital element on the real world. That is typically called augmented reality. So we have the reality and we see the reality, and this is augmented with digital elements. There are typical holograms, messages, text. And in this case, we have augmented virtuality, in which the virtual features, the virtual world, this is a 3D representation of the virtual world, is augmented with a realistic representation of the real world surrounding us. We've done project, so this is called in the literature virtual continuum, and any combination that is in this virtual continuum interval is called mixed reality. So mixed reality includes both virtual and augmented virtuality and augmented reality, and because it's typically an intermix between the digital and the physical. Also, when you make something totally fictitious, totally digital, I mean, you should find a way to keep a reference to the real world. And these are example in this continuum, and you can see it in the slides. So you can superimpose, you can use different devices. You can use your smartphone to superimpose a digital character on the back, on the surrounding space. You can have more sophisticated elements such as HoloLens technology, in which you wear spatial visors and you see the surrounding world with the digital content superimposed to it. You can have a solution in which you put, for example, your hands in the view in a 3D digital reconstruction of something, and or you can simply have, like in video game, a virtual, fully digital environment, which more different levels of realism, depending on the user experience that you want to achieve. Virtual reality can be more or less immersive. Depends on the device and the technology you use. This is an example of cave in which virtual reality is, you have projection on all walls surrounding the user, so that he has the feeling of being really immersive. So these are examples of large-scale virtual reality that use large-scale display. On the opposite, you have virtual reality on headsets, very simple cardboard glasses in which you insert a mobile phone, and by looking at the mobile phone screen through these glasses, we have the effect of immersiveness. And this is the main technology that we use. Head-mounted devices, typically low cost, either like Google Cardboard, really paper-based stuff, or slightly more robust, like in this case. But in both cases, we put the computer, the smartphone inside it. So this is the structure. And this is the idea. The idea is that indeed in the smartphone, there are two images, like in this case on the left, by placing, but the effect for the user using the visor here, the viewer, the glasses, so the glasses inside the visor, there is an effect, a cognitive effect in our mind, so that the two images become combined in our brain, and you have an effect of surrounding, of a curving field view. So these are flat, so the images are two and are flat in the two-dimensional smartphone. But by effect of the lens, and some cognitive process in our mind, you see them as a unique image, which is curved, which is 360 degrees. We did a number of projects, again, starting with children with special needs. So we transformed some stories into stories in immersive virtual reality to be used on the cardboard. They, let me see, well, some place I say that, I don't remember where, at some point I say how you interact with this content. So you interact with this content, maybe here, you interact with this content, basically focusing on the content. So you focus on a content, but you have the impression that you are controlling it through your eyes, but indeed you are controlling it with your head. So there is an implicit assumption that what you are pointing to is what is defined by the line connecting your eyes to the projected image. So basically is the direction of your eye that determines what is pointed. And when you point to something, there are two little pointers, visual elements that let you know where you're pointing to. But again, you are not pointing with your eye, you are pointing with your head. So we defined a number of activities, stories, or a simple game finding items in a space, sort of treasure hunts. We define also spaces in which has particular shapes in order to help people learn how to control the environment. We were able to do automatic data gathering, so that we were able to automatically track the points, the point where the user was looking at, and model the different level of attention. So the many times in which user was pointing to right or wrong things. So there are papers that are available in our website that you can find about this issue, but the idea that you can use technology devoted to play, to entertain, to learn, to gather relevant data about the user, about user behavior, about the user cognitive state. And we did this empirical study at a center in which children with some disability use it with their therapist. We also make measure of the user ability to control the view pointing, and we were able to track their trajectory of view in the labyrinth. Another project was devoted instead to use 360 videos and to simulate the so-called social stories, so stories of everyday life that were first represented through pictures, and then rendered to video recorded in real environments. So this is a social story about going to the museum, and then we translated it into an interactive experience with fragment of 360 videos collected at the museum. Then the next step, more advanced step, was with the HoloLens, Microsoft HoloLens for virtual reality. This is an expensive device. It costs approximately 2,000 euros. The new release, the new version that we have ordered and we are waiting to achieve costs 3,000. It's basically able to, it's a hand-mounted glasses, and a lot of technology is relatively heavy. They can do spatial mapping, so they can dynamically understand the different surfaces in the space, so that they can dynamically place holograms, digital element in this view of the real world. So this is the most popular example of augmented reality. Again, the idea is head movement to point. So it's what you point at that you take. There are also interactive movement head pitch. Finger pitch. So air tap to select. That is something that they are replacing in the new version because it was really hard to use. There are also clickers, other element, and there are also voice commands. So they're integrating voice as an interaction mechanism. We made several experiments, several applications. I took this picture because, imagine that, this is our virus, and this is not our virus, this is a sort of protein structure, but it was a nightmare to use virtual reality to see all the viruses that are around us. Okay, we made this application which is called Memolo to improve memory. So this is a regular space, and you dynamically superimpose boxes, and the idea is to play memory with these 3D boxes. Let's see if I have, okay, this is a video.
People with neurodevelopmental disorders need to learn things that we take for granted, such as
One characteristic is that we have a conversational, it's a companion, a virtual assistant, which in this version was able only to do some back-channeling effect. So say, great, wow, wow, and similar. Now we are integrating, we're transforming it into a real conversational agent that can engage people in conversation while doing experience in online. Just show you another. Okay. We did a number of empirical studies with this device. We also integrated it with smart object. So trying to figure out how mixed reality can communicate with physical, digitally enhanced object. And we develop a number of games, small games, in which the user has a view of the surrounding world, enriched, enhanced with digital element, and interact with this digital element in the real world using an object like the dolphin. Okay, so this is okay. I was planning to explain you another set of slides, but there is no time for that. Anyway, the slides that I have not presented are in BIP already. I will try to create a light version of these slides to be able to post them as in BIP as well. And I will send you a message through BIP for the YouTube channel where you find all the video of our projects, for all project of students, international project, national projects, everything. So if you want to have time to have a look, you can go. I will not go back as I hoped to the issue of how to do the exam, what to expect from the exam. So from the documentation, okay. I will not go back to the issue of how to create the technical documentation because some methodological aspects of the documentation are explained in the slides that I'm not able to present for lack of time. So in the next lesson, I will devote some time to present that methodological aspect, because the thing that you have to describe in your technical documentation should follow the example and the methodology and the approach of the models, the so-called models presented in those slides. So I will stop recording now. This recording appear in the chat when they are ready, so you can click. You should be able, if you are enrolled in the course, you should be able to access all these videos from streams. But as soon as we'll be able to download them from Teams, which takes time because in this period everything, I mean, the video management is crazy. I will communicate with you and tell you where you can find all these videos. So I stop recording.